Hello friends, welcome to Jatin's Academy. So today in this class we will learn about chapter 3 machine part B. So in part B we will totally focus on the pulley system. So in this chapter we will learn about the introduction of pulley. After that we will see single pulley. In case of single pulley we will see about the fixed pulley. After that we will see movable pulley. Next we will see about combinations of pulley. In combination of pulley two cases are there. One case we have using one fixed and another movable pulley. Next we will see about using several pulley in two blocks, that is block and tackle system. So let's get started. So what is a pulley? Pulley is basically a circular disc which is rotating about its center, and through the center a rod is passed, that is a axle. So if I am talking about the body parts of a pulley, first we have a frame. So this is a frame which is attached with the rigid support about which it's actually giving a support to the pulley. Next we have a disc. So disc is basically this circular part which is actually rotating about its center. Next we have a axle. A rod is passed through the center of the circular disc. So this rod is called axle. Next we have grooved rim. On the pulley we have to attach a rope. So this rope will not slip. So to avoid the slippage we have provided some groove on the pulley. So this is basically a grooved rim, okay, in which rope is passed. Next we have to see how we can use a single pulley. Single pulley we can use in two ways. That is, first we have fixed pulley and second we can use it by a movable pulley. What is the meaning of fixed pulley? Fixed pulley means the pulley whose axis of rotation is not moving or fixed. For example, this pulley is rotating about its axle. So this is the center of the pulley. So this center of pulley or axis of pulley is not changing. It is fixed at a point. So this pulley is called fixed pulley. In the movable pulley, the axis of rotation about which, for example, this is the axis of rotation which is moving in the upward direction. This is moving. So a movable pulley whose axis of rotation is movable means it is not fixed at a one position. It is called as a movable pulley. Clear? So now let's understand one by one the mechanical advantage and velocity ratio of each pulley. First we have single fixed pulley. Now what is the meaning of single fixed pulley? The meaning of single fixed pulley is that the axis of rotation is fixed. What is the meaning of axis of rotation unchanged or fixed? It means that, for example, this is a pulley which is fixed at this point. This is the axle of the pulley or axis of rotation. So this axis of rotation will not move. It is fixed at one point. So where the axis of rotation is not moving and fixed at one point, that is called as a fixed pulley, and this is a one pulley, that is why it is called as a single pulley. Now we have to see the mechanical advantage. So before understanding the mechanical advantage, let's see when you are applying the force on the pulley, what is actually happening. So here you are applying the force in the downward direction. So the force applied by the person on the machine, that is called effort. So you are applying force in the downward direction. So when you are applying force on the string, what will happen? A force is produced in the string. So that force is called tension force. When you apply the force on the string gets stretched. So this stretching of string is because tension is produced in the string. So one string is having one tension. This you have to remember. Single string is having single tension. So this tension is uniform at this point as well as this point. This is the block. It is actually a load for a machine. Okay. So now if you will see the free body diagram means you are taking this one part of a machine. So if you will take a effort point, here tension is in the upward direction and effort is in the downward direction. So according to Newton's third law of motion, that tension and effort are opposite to each other, so equal and opposite. So effort is equals to tension, they balance each other. Similarly on the load point, tension is in the upward direction and load is in the downward direction. So here we got load is equals to tension. So now let's calculate the mechanical advantage. Mechanical advantage, we have load upon effort. So what is the value of load? Load we have calculated as tension, and mechanical effort we have tension. So tension cancel out. So mechanical advantage we got it as 1. Clear? So mechanical advantage of single fixed pulley, ideal case, we have mechanical advantage as 1. Now let's calculate the velocity ratio. Velocity ratio means velocity at the effort point over velocity at the load point. You can also convert it into displacement. You can also write displacement at the effort point over displacement at the load point. Now carefully see, when this string is here and you move the string up to this point, so this is the displacement of effort. So in the single fixed pulley, when the effort point is moving some distance, the load is also raised the same distance. It means that displacement of effort and displacement of load is same for a single fixed pulley. So if they are same, then velocity ratio, again put dE as dl by dl. So velocity ratio we got it as 1 value. So mechanical advantage we got it as 1 and velocity ratio we got it as 1. Now carefully see, when mechanical advantage is 1 and velocity ratio is 1, which machine is this? This is the machine in which there is no speed gainer, no force multiplier, only there is a change of direction of force. So this machine is act as a change in the direction of force to the convenient point. So here we are changing the direction of force to a convenient point. How? Carefully see, applying the force in the downward direction is convenient for a human being, and here we are applying the force in the downward direction, but load is raises up in the upward direction. So this machine acts as a change in the direction. Clear? Now here note one thing, that for a single fixed pulley, mechanical advantage is 1, velocity ratio is 1, and it acts like a change in the direction of effort. But this mechanical advantage 1 and velocity ratio 1 is for an ideal machine. So what about the actual machine? In case of actual machine, so many losses are there, friction losses are there. So due to the friction losses, efficiency is not 100%. For ideal machine, efficiency is 100%, but in case of actual machine, efficiency is not 100%. When efficiency is not 100%, then something get changed. What that thing get changed, that we have to discuss. For an actual machine, velocity ratio remains same. Velocity ratio does not change. With the case of ideal or actual machine, means for losses velocity ratio will not change. Then which value will change? Mechanical advantage will change. So mechanical advantage value will reduce, will get less than 1, because it is having mechanical advantage 1. Now the velocity ratio is less than 1. Why? Because some effort is required to overcome the frictional losses. So there is a difference between the ideal fixed pulley and actual fixed pulley. Clear? Here mechanical advantage only gets changed, velocity ratio will not change in any case. Next type of pulley we have single movable pulley. Single means it is a one pulley, and movable means its axis of rotation is moving. Where is axis of rotation? Here we have a axis of rotation. So single movable pulley means the pulley whose axis of rotation is movable. Now we have to calculate the mechanical advantage of this pulley. For calculating the mechanical advantage, we have to apply some effort here. Okay, so when you are applying the effort, a string gets stretched, means a tension is produced in a string, and you have to remember that one string is having a common tension, same tension throughout the string. So here we have a T tension and here we have a T tension, and this is a block which is actually a load for this machine. Now we have to see the here derivation. Now just take a free body diagram. Free body diagram means we have to cut the portion of the machine and check the number of forces acting. So if you will see this portion, here two tensions are applying in the upward direction and load is acting in the downward direction. So two tensions are acting in the upward direction and load is acting in the downward direction. So here we got 2 times tension is equals to load. This is our first equation. Now we have to see the second equation. Carefully see, when effort is applying in the upward direction, for the effort tension direction is downward. But here you will get confused. Why? Because at the lower point, at this point, I have made tension in the upward direction. Now I am making a tension in the downward direction. Now carefully see, for this pulley, load is acting in the downward direction. For this load, tension is produced in the upward direction. But if you will see this portion, at this portion, effort is applying in the upward direction. And for the effort, tension is applying in the downward direction. So if we will balance the forces, effort is equals to tension. Now we have to see the mechanical advantage as load upon effort. So load value we got it as 2 times tension and effort value we have calculated as tension. So cancel it out, we got mechanical advantage as 2. So mechanical advantage from this figure we have calculated is 2. Now we have to calculate the velocity ratio. For the velocity ratio we have displacement of effort over displacement of load. So here you are applying the effort, so this is the displacement of effort, okay, and when you are applying the force, whole string will move in the upward direction, so load will also move in the upward direction. This is the displacement of load. Here you have to carefully one thing, that when this displacement of effort move upward by a distance d, this string is moved by a distance d by 2 and this string is moved a distance d by 2, means both distance half and half, from both side half and half string is moving to completing the d displacement. It means that when half and half string is only moving, so load is only moving by d by 2. This is actually an experiment, but here you have to see like this, that when effort is moving in the upward direction with displacement d, then the load is only moving half of the value. So displacement of effort we have d and displacement of load we have half of the displacement of effort, that is d by 2. So here denominator of denominator become numerator, so 2 times d upon d. So here we got velocity ratio as 2. Mechanical advantage we already calculated as 2. Velocity ratio we have calculated as 2. So when velocity ratio and mechanical advantage is 2, so this movable pulley, single movable pulley, act like a force multiplier, because we know that when mechanical advantage or velocity ratio value is greater than 1, that machine is act like a force multiplier. Force multiplier means what? Here if you want to raise the load of 50 kgf, you have to apply only the force of 25 kgf. So here your half of the force is saved, half of the effort is saved. This is called as a force multiplier. But there is one problem with this pulley. Can you tell me which problem it is? So this problem is that the here effort we have to apply in the upward direction. Upward direction is convenient for us or inconvenient for us? Applying a force in the upward direction is inconvenient for us. So this single movable pulley is inconvenient for a human. So how we will make this single movable pulley from inconvenient to convenient? But we want the same mechanical advantage and velocity ratio. So this we can done by the way to change the direction of effort. How we can change the direction of effort? By attaching a single fixed pulley here. Now you will attach a single fixed pulley here, so the direction of the effort we can change easily. So here this is the effort point, this is again tension and tension is produced. Same thing, this pulley act as a movable pulley whose mechanical advantage is 2 and velocity ratio is 2, and this pulley act like a single fixed pulley whose mechanical advantage is 1 and velocity ratio is 1. This pulleys act as a force multiplier and this pulleys act as a change in the direction of effort to a convenient point. Clear? Next we have to see the difference between the single fixed pulley and single movable pulley. So first point we have, in a single fixed pulley, it is fixed to a rigid support. Here the pulley is fixed to a rigid support, it is not moving. But movable pulley is not fixed to a rigid support, so it is moving. So it is ideal mechanical advantage is 1. For an ideal fixed pulley, mechanical advantage is 1. In this case, for an ideal pulley, mechanical advantage is 2. Its velocity ratio is 1. Single fixed pulley velocity ratio is 1 and for single movable pulley velocity ratio is 2. Now carefully see this point. For a mechanical advantage, they are using the word ideal. Ideal means whose efficiency is 100%. But for the velocity ratio, they are not using any word ideal. It means that for the actual machine, only mechanical advantage value will reduce, but velocity ratio value will not reduce. Clear? So next we have the weight of the pulley itself does not affect the mechanical advantage. In single fixed pulley, as it is fixed to a rigid support, so the weight of the pulley does not affect the mechanical advantage. But in case of movable pulley, as carefully see, in case of movable pulley, here we have a block attached. So here we are applying the effort. If this pulley is too much heavy, then we have to bear the load of the pulley as well. So here mechanical advantage will change according to the weight of the pulley itself. So weight of the pulley is significant here, but weight of the pulley is insignificant in case of single fixed pulley. Next we have to change the direction. So here single fixed pulley is used to change the direction of effort from upward to downward, but single movable pulleys act as a force multiplier. Next we have the load move in the direction opposite to that of effort. Carefully see, here we are applying effort in the downward direction and load is raised in the upward direction. So load moves opposite to the direction of effort. But in the single movable pulley, you are applying the effort in the upward direction and load is also moving in the upward direction. So load moves in the direction of effort. Next we have here the axis of rotation does not change, it is fixed. But here in the single movable pulley, axis of rotation gets changed. Clear? Next we have combination of pulleys. In order to lift up a heavy loads, we are required number of pulleys. So in case of one pulley, we have seen that single fixed pulley is only used to change the direction of force. And movable pulley can give the mechanical advantage, but its mechanical advantage is very less, only 2. But if you want to require a large mechanical advantage, then you have to use a combination of pulleys, means a number of movable pulleys along with fixed pulley to change the direction of force. So basically for the combination of pulley we have two arrangements. First we have using a one fixed pulley and several movable pulleys. Here fixed pulleys act as to change the direction of effort to a convenient point and several movable pulleys act as a force multiplier, okay, and it is attached to a same rigid support. Next we have a using several pulleys in two blocks, that is block and tackle system. Both system we will see in the detail. So first we have using one fixed pulley and another movable pulley. So here we have this fixed pulley whose mechanical advantage we have 1 and another so many movable pulleys. Here we are using 3 movable pulleys. Now one by one we will see each and everything. First we have to calculate the mechanical advantage. So now we have to attach the strings. So now carefully see, first string we will attach with the support and another with this pulley, and again from support another to this pulley, again from support another to this pulley, and this is a changing the direction of effort. Now we have to calculate the tensions and we have to see the mechanical advantage. So before calculating the mechanical advantage, let's see the tension in a string. You have to remember one thing, that one string is having one tension. So this is a one string. So tension is constant in this string, that is T1 and T1. Clear? Here we have a second string. In this string we have a tension. Complete string is having tension T2 and T2. Here we have a third string, tension T3 and T3. Now carefully see, this string is extended up to a fixed pulley. So here we again have a tension T3. Here we are applying the effort, and here it is a load that we have to raise. Now we have to calculate the mechanical advantage. Mechanical advantage formula, we have load upon effort. So basically we have to calculate the relationship between load and effort with the help of tension. How we will calculate? Carefully see. First we will see the free body diagram of this pulley. For this pulley, two tensions are applying in the upward direction and load is acting in the downward direction. So two tensions in the upward direction and one load is in the downward direction. So here load we got it as 2 times T1. Okay. Now we have to focus on this part. Carefully see this part. This is important. So now for this part, see, for this pulley, tension is in the upward direction. But for this pulley, this same tension is act in the downward direction. Clear? So two times two tensions T2 and T2 balancing the T1. So T2 plus T2 is equals to, here we have a T1. So here T1 we got it as 2 times T2. Clear? T1 we got it as 2 times T2. Now let's see the third pulley. So for the third pulley, this pulley, we have this tension is acting in the downward direction for this pulley. So here two tensions in the upward direction, that is T3 and T3, and one tension, one force is acting in the downward direction, that is T2. So here we got T2 as 2 times T3. Clear this part? After that, for a single fixed pulley, here you just see, here effort and tension both balance each other. So here effort is equals to T3. Now we have to make a relation. Now put the values. Here T1 value is 2 times T2. Put here T1 value. So here T1 value I am substituting as 2 times T2. Okay. But we want the relation in T3. Why? Because effort is in T3. So here this become 2 into 2, 2 square, not 4, 2 square we will write here. Now here we know that T2 is equals to 2 times T3. Put the value here, T2 as 2 times T3. Clear? So here load value we got it as base same at the power 2 power 3 into T3. So load value we got it as 2 raised to power 3 T3. Now we have to calculate the mechanical advantage. Mechanical advantage, we have load upon effort again. So load value we got it as 2 raised to power 3 T3, and effort we have, effort is equals to T3. So this tension 3 and tension 3 is cancel out. So mechanical advantage we got it as 2 raised to power 3. Now carefully see here. Here we have three movable pulley. First movable pulley, second movable pulley, and third movable pulley. So three movable pulley, its velocity, mechanical advantage and velocity ratio is 2, here 2, here 2. So both are actually multiplying. So here we got it as 2 raised to power 3 for 3 movable pulleys. Okay, so 3 movable pulleys, we got mechanical advantage as 2 raised to power 3. But for n movable pulleys, if we have n number of movable pulleys, then mechanical advantage we got it as 2 raised to power n for n movable pulleys. Clear this part? Now we have to calculate the velocity ratio. So velocity ratio is what? Velocity ratio is displacement of effort over displacement of load. Here we are applying the effort. So here we got displacement of effort. For example, this is D, and here we got it as displacement of load, that is DL. Now carefully see, here it is a fixed pulley. So if it is a D displacement, here it is also a D displacement. But for a movable pulley, the displacement of this point is only D by 2. This we have done in the movable pulley, that if effort is moving a D distance, then this load is moving only D by 2. And for this pulley, if effort is moving a D distance, this load at this point is only moving D by 2, means half of this value. Half of this value means D by 2 square. And if this this effort is moving D by 2 square, so this load is only move half of this, that is D by 2 square, half of this value. This we have done in the single movable pulley. So now here we got it as D by 2 cube. So now here displacement of effort we have D, and displacement of load we have D over 2 raised to power 3. So here 2 cube is going in the numerator, D by D cancel out. Velocity ratio we got it as 2 raised to power 3. So for 3 movable pulleys, velocity ratio is 3. For n movable pulleys, velocity ratio is 2 raised to power n. So now let's generalize the term. Here mechanical advantage we got it as 2 raised to power 3, and velocity ratio is 2 raised to power 3. For example, let's take the value as it is 8. So mechanical advantage 8 means greater than 1. So this fixed pulley along with the combination of movable pulley act as a force multiplier. So this whole system act like a force multiplier. Let's take the value and calculate how much mechanical advantage we are getting here, means what benefit we are getting from this system. For example, we have a block of 1000 kg. Okay, now how much force we have to apply here in order to lift up this 1000 kg? Carefully see, mechanical advantage we have load upon effort. Okay, kgf you can write here because it is a force, effort we have to calculate. Mechanical advantage here it is a 8. Load value we have 1000, and effort we have to calculate. So effort we got it as 1000 by 8. So when you will cancel out, you will got effort as 125 kgf. Now carefully see, here you have to apply only 125 kgf of force in order to lift up a 1000 kgf, which is very small value in front of this 1000. Clear? Next combination of pulley we have block and tackle system. Now what is the meaning of block and tackle system? In block and tackle system basically we have two blocks. So this is our first block which is made up of fixed pulleys, and this is our second block which is made up from movable pulleys, means these pulleys can move up and down, but these pulleys are fixed and only rotating about their axis. So this is the first block which is having also called upper block. This upper block contain fixed pulleys, and this is a lower block. In case of lower block we have movable pulleys. Now if I am talking about if number of pulleys are even and if number of pulleys are odd. For example, in one case I have 4 pulleys and in second case I have 5 pulleys. Then how I will arrange? When 4 pulleys are there, then 2 pulleys goes to the upper block and 2 pulleys goes to a lower block. But if 5 pulleys are there, odd number of pulleys are there, then we have to take one more pulley extra in case of a fixed or upper block. So here we will see 3 pulleys and here we will take only 2 pulleys. So here we got a 5, and if 4 then 2 and 2. So it means that number of pulley used in the movable lower block is either equal to or one less than the upper block. Clear? Now one by one we have to see the pulleys, different pulleys arrangement we will see, and we will calculate the mechanical advantage and velocity ratio. So first system we have block and tackle for 5 pulleys and convenient direction. Now what is the meaning of convenient direction? Before that, block and tackle for 5 pulleys. So here we have a 5 pulleys. Now we have to draw this pulley in the convenient direction. We have to make a thread or use a thread or a string in such a way that it is forms a convenient direction. Now tell me, which is our convenient direction, downward or upward? So for a human being, convenient direction is downward. So what we will do, carefully see, from the down we will use this string, this massless string. We have to attach one by one from one pulley to another pulley, okay, and finally attach to a hook. So when number of pulleys are odd, or you can say 5, then for a convenient direction the string is attached to a lower hook. Lower hook means it is attached to a lower block hook. Okay, this you have to remember, or you can also draw. Now we have to see the mechanical advantage and velocity ratio. So here you have to draw the tension in the string. Basically here we will apply the effort, okay, and this is a load. Now carefully see, for one pulley means moving from one pulley to another pulley, we have to draw one tension. So from hook to pulley, one tension. From one pulley to another pulley, one tension we have to draw. Again from this pulley to this pulley, one tension we have to draw. From this pulley to this pulley, one more tension we have to draw. From this pulley to last pulley, one more tension. Okay, so these are the tension that we have drawn, and for the effort, tension is applied in the upward direction. So this tension is only for the effort. Now here effort is equals to tension. If you focus only on this part, effort is equals to tension. And now if you will see this block and tackle system, load is acting in the downward direction, and how many tensions are acting in the upward direction? Don't see this tension, this is for only effort. So count 1, 2, 3, 4 and 5. So total 5 tensions are acting in the upward direction, which is able to handle this load. Okay, so mechanical advantage we have, that is load upon effort. Load we have 5 tensions and effort we have tension. So cancel it out. So mechanical advantage in this case we got it as 5. So mechanical advantage of this system is 5. Now let's see the velocity ratio. Now this, if effort moves a distance of d, for example, the load moves a distance of d by 5 only. Why? Because these strings are moving in such a way that only some part of the strings will move. So if some part of string will move, 5 strings are there, so load will only move d by 5. So here velocity ratio we have displacement of effort over displacement of load. So this is the effort point, here displacement of effort is d, and this is a load point, here displacement of load is d by 5. So here we got it as velocity ratio 5. Now carefully understand this term. From this only we will understand each and everything, that if number of pulleys are 5 and the direction is convenient, then we have mechanical advantage and velocity ratio equals to number of pulleys. And what about the efficiency? Efficiency we have mechanical advantage over velocity ratio. Mechanical advantage 5, velocity ratio 5. So efficiency we got it as 1, which is 100%. So here we are not considering any losses. So efficiency of this block and tackle system is 100%. Now here for 5 number of pulleys for a convenient direction, mechanical advantage is 5 and velocity ratio is 5. Now we have to see block and tackle system for 4 pulleys. For convenient direction, carefully see the string. Convenient direction means we have to start from here. So carefully see the string. The string is moving from one pulley to another pulley. Like this you have to draw. Okay. Now in case of the convenient direction for 4 pulleys, the string is attached to the upper block or upper hook. Clear? Now again if we will see effort, here this is a tension for effort. There is one tension from one pulley to another pulley, another tension, one pulley to another pulley, one more tension, one pulley to another pulley, one more tension. Okay, So basically we have 4 tensions handling for one load and one effort is handling one tension. So here mechanical advantage and velocity ratio we have again 4. Clear? Now we have to see very important case, block and tackle system for 4 pulleys in inconvenient direction. So what is the meaning of inconvenient? Inconvenient means we have to take the direction from this side, means now we are moving the pulley in the upward direction. We are using an inconvenient direction. So here this string is moving from this point to this point, from this point to this point. Like this you have to use string. After that I will make also. So here you have a block and tackle system for inconvenient direction. Now carefully see, here it is a string attaching in such a way that it forms an inconvenient direction, and here it is attached to a lower block. Now carefully see, here this inconvenient direction block and tackle system is only possible for even number of pulleys, either 4 or 6 or 8, like this. Like 5 or 3, these inconvenient direction is not possible. You can try by making 3 pulleys and try to make the string you are not able to make appropriately, means it will not touch each and every pulley. Now here we have to see about the mechanical advantage and velocity ratio. Effort is applied in the upward direction, and for this effort tension is in the downward, but for this pulley tension is in the upward. For this pulley tension is in the upward. This pulley to this pulley tension upward. This pulley to this pulley tension upward. This pulley to this pulley tension upward. Now here we have upward tension 1, 2, 3, 4, 5. So total we have load is able to handled by these 5 tensions and effort is only handled by this tension. Clear? Now inconvenient direction if we are getting, then one more benefit we are getting, that mechanical advantage is increasing. So for inconvenient there is an increase in the mechanical advantage. If we have 4 pulleys, then mechanical advantage and velocity ratio must be 4, but here we are getting mechanical advantage as load upon effort, which is 5t upon t, which is 5. So mechanical advantage we are getting 5, velocity ratio we will also get 5. So it means that although if it is an inconvenient direction, but one benefit we are getting, that is it is a having more mechanical advantage than 4 pulleys. So here we have mechanical advantage 5 and velocity ratio is also 5. Clear? Now let's summarize the things. So here we have basically number of pulleys n. Okay. So here we have two cases. Either the number of pulleys are odd or the number of pulleys are even. If the number of pulleys are odd, then mechanical advantage and velocity ratio is equals to number of pulleys. Or next we have number of pulleys even. So if number of pulleys are even, then further we have two cases. So first case we have convenient direction and second case we have inconvenient direction. For convenient direction, mechanical advantage and velocity ratio is equals to number of pulleys, and for inconvenient direction, mechanical advantage and velocity ratio is 1 more than number of pulleys. So basically if you have 4 number of pulleys, then for this is the even number means for convenient direction mechanical advantage is 4, velocity ratio is 4, and mechanical advantage for inconvenient direction is 5 and velocity ratio is 5. Clear? Now we have to see the work input and work output for block and tackle system. So what is the meaning of work input? Work input means we have work is equals to force into displacement. Input means we are applying the force on the machine, which is a effort, and at a which point, at the effort point, here we have a displacement of effort. So here we are applying effort and this string is moving. This is called displacement of effort. And what is the meaning of work output? Work output means force into displacement. Force, how much the machine is apply the force on the load. Okay, so this is basically a load, and displacement at the load point we have displacement of load. Now we have to make that what is the relationship between work input and work output. First of all, see the relationship between load and effort. For example, for n number of pulleys, this is a 4 pulleys, take n number of pulleys. When n number of pulleys are there, mechanical advantage is equals to n, which is equals to number of pulleys, and velocity ratio is also n. What is the formula of mechanical advantage? Mechanical advantage we have load upon effort. Okay, so from here load we got it as n into effort. Put the value of load here as n into effort into displacement of load. Okay, next we have velocity ratio. Velocity ratio formula we have, that is displacement of effort over displacement of load, which is equals to n. So from here displacement of effort we got it as n into displacement of load. Put the value of displacement of effort as n into displacement of load. So here it become NEDL. Now carefully see. Work input we got it as n number of pulleys, effort into displacement of load. Work output we got it as n into effort into displacement of load. It means these quantities are same, so these quantities are also same. It means that work at the input point is equals to work at the output point. It means this show the conservation of energy. Conservation of energy means the energy can neither be created nor be destroyed. It can transfer from one point to another point. It can only transfer from one point to another point, provided that here we are neglecting the losses, frictional losses and other losses we are neglecting. If there is some losses, then some part of energy is lost in overcoming that losses. Clear? Now let's see the effect of weight of pulleys on mechanical advantage, velocity ratio and efficiency. Now carefully see, in the previous derivation we have not considered the effect of the weights of these movable pulleys. Here we have two types of pulleys, fixed and movable. So fixed pulleys are fixed at one point, they are just rotating, they are not moving. So effect of weight of these fixed pulleys we are not considering. But here movable pulleys are having some weight, so this weight is acting in the downward direction and load is acting in the downward direction. So when you are applying effort at this point, here you are not only making the load or not only taking the load in the upward direction, but also taking the effect of weight, also taking the weight of the pulley in the upward direction. If these pulleys are very heavy, then you have to apply more force in order to raise the load as well as these movable pulleys. So now we will see the effect of the weight of these movable pulleys. Now if you will see, for example, here we have n number of pulleys. So for n number of pulleys, n number of tensions are able to take the weight of the pulley and the load. So load and weight is acting in the downward direction and n number of tensions acting in the upward direction. After that, in the effort point, effort is acting in the downward direction and in the string, for that tension is balancing, so effort is equals to tension. Now carefully see, mechanical advantage is equals to load upon effort. Load value we have, that is nt minus w, and here nt minus w over effort. Now here T is equals to effort, so replace this tension with the effort. So here it is replaced. Okay, so here we got it as, now divide separately. Mechanical advantage formula we got n effort upon effort minus weight of the pulleys upon effort. So here we got mechanical advantage as n minus weight of the pulleys upon effort. So this is the mechanical advantage formula when we are considering the weight. So now mechanical advantage we have n minus weight of pulley upon effort. So what about the velocity ratio? In case of effect of any pulley, the displacement of load and effort will not change. So even though you are taking the effect of pulley, the displacement part will not change, so velocity ratio will not change. Velocity ratio will remain same. For n number of pulleys, velocity ratio we got it as n. Now we have to calculate the efficiency. Efficiency we have mechanical advantage over velocity ratio. Now just divide here mechanical advantage over velocity ratio efficiency, N minus W upon E divided by N. Just separately divide it. So here we got it as efficiency, that is 1 minus weight of this movable pulleys divided by n number of pulleys into the effort which we are applying. Now if you want to increase the efficiency, how you will increase the value of efficiency? Just by decreasing the weight of the pulley. So in order to increase the efficiency of the pulley, you have to take the pulleys as light as possible. Clear? So here we have efficiency is 1 minus weight of this movable pulley over number of pulleys into effort. Now when you want to increase the efficiency, for greater efficiency, the pulleys in the lower block should be as light as possible and the friction between them should be minimized. Then only we are able to get a more efficiency for a block and tackle system. Clear?